Hello everyone, welcome back to my YouTube channel. Today we have a really special paper that we will be looking into. And this paper right here called LLMs Still Can't Plan. Can LRMs? A preliminary evaluation of OpenAI's O1 on PlanBench. Okay, so what this paper is essentially talking about, it's talking about whether or not the current state of the art LLMs are able to create accurate plans, right? And it turns out that from the past to even now, it is unable to create a cohesive plan that one can use, right? It is only good at writing stuff, but it can't really plan that well. And the question now is, with the release of OpenAI's a new AI called the O1 model, specifically the preview version, is it able to plan? And that's the question that this paper is going to uh, address. But before that, I would like to introduce you to my Patreon. So by becoming a member in my Patreon, you will be able to support the channel, access the annotated papers that I do for every single video on YouTube, and you also get to vote on which paper or topic that you want me to cover in the next few videos, right? And your name will be in the credits as a way to say thank you for your support. Okay, so with that out of the way, let's get right into the paper now. So, okay, as usual, we need to go through the abstract to get an idea about the entire paper. So let's get started, shall we? Okay. The ability to plan a course of action that achieves a desired state is considered to be the core competence of intelligent systems like humans or even cats, right? Right. And it's something that we need to consider a lot in AI research. Okay. And the advent of LLMs, during the advent of LLMs, there's a lot of interest in whether or not they are able to plan. So 2 years ago, they released a benchmark called PlanBench, right? Soon after the release of GPT-3. So that's like a while back ago. Uh, yeah, and they say it is a useful tool for evaluation the planning abilities of LLMs to now. And what they say here is pretty depressing. Despite the improvements of the LLMs over these 2 to 3 years, yeah, they aren't necessarily doing that well in their benchmark. So but now is a different story, right? Since OpenAI released their O1 Strawberry model, and they call it a large reasoning model, LRM, right? And the question now is it really that good, right? Is it able to plan, right? And not surprisingly, right, due to its ability to perform chain of thought, which has been improved using reinforcement learning, of course, it is going to be a major improvement over the other LLMs, right? But it is apparent that, right, even though it is a major improvement, it it doesn't really reach to that point which it is like consistently making good plans ahead, right? So this is what we will be looking through right now, okay? But before that, let's go to the conclusion, because by reading the conclusion, we get to know the overall ideas and findings behind this paper. Okay, let's go through the conclusion now. All right. So they have a look at the planning capabilities of both state-of-the-art models and found that the performance of OpenAI's O1 models, on PlanBench. So over time, LLMs have improved their performance on blocks world, with the best performing model, which is Meta's largest open source Llama model called Llama 3.1, which is 400 plus billion parameters, and it gets around 63% of accuracy here. But yeah, but despite that performance, right, they score pretty badly in the mystery versions of the same domain, right? The and that kind of shows that they have this approximate but not perfect way of retrieving nature. So okay, and to say that, in contrast, the new O1 models, and they call it the LRMs, right? Right, it nearly saturates the original small instance block world test set. Okay, but before we get any before we go on, we need to know what the block world test set means, right? So let's go through. Okay, so AI block world test set. Okay, let's see. Okay, now we look into Wikipedia here. Yeah, and it does have a pretty good explanation here, right? So for those of you who do not know what block world is, it is basically a planning domain in AI. So yeah, I kind of forgot how it works, but let's just read through the this paragraph here. Okay, so the algorithm is similar to a set of wooden blocks of different shapes and colors sitting on the table. The goal is to build one or more vertical stacks of blocks, and and the condition is that you can only move one block at a time. All right, so it can be either placed on the table or placed atop another block. And due to that, any blocks that are under another block cannot be moved. Moreover, some kinds of blocks cannot have other blocks stacked on top of them. Okay. So let me just get this straight, right? So the first thing, okay, so the goal is to build vertical stacks of the blocks, and I would assume that finding like the best way to build them higher and higher while being in the constraint of the game, right? Okay, and the constraint is that okay, you can only move one block at a time, right? And and the other constraint is that okay, you can either place it down on the table or place it on top of another block. Got it. And because of that, wait, just a second. Oh, never mind. Okay, right. And because of that, okay, any blocks at any given time under another block, right? If a block is under another block, that block cannot be moved. Okay, so that's the third condition. And the fourth condition is that some types of blocks cannot have another block stacked on top of them. So, for instance, if block A cannot have block B stacked on on top of it, then only C is allowed to be on top of A, right? Because B is restricted to be on top of A. Okay, so this is kind of a symbolic AI test, I believe. Yeah. So with that out of the question, let's go through it, shall we? Okay. So so the O1 model essentially did really well for the block world test set. Okay, and they say here, but shows the first bit of progress on some versions, right? So encouraged by this, they evaluated O1's performance on longer problems and unsolvable instances, and found that these accuracy gains are not general or robust. And this is kind of sad. Okay, we also discussed the critical accuracy or efficient trade-offs that are brought by the fact that the O1 model uses significant inference time compute, as well as how it compares to other LLM approaches, such as LLM, modulo, and other dedicated solvers. Okay, so that's a general gist of what they found. So let's go back to the top. Okay, and since this is a pretty short paper, how about we just go through the introduction now? Okay, so so it has been a while since the O1 model has been released, right? And it basically outperforms even GPT-4o, right? In many different areas like physics and mathematics, right? But for things like creative writing, it actually performed worse a bit. So that's that, right? Okay, so the O1 model brings opportunity to both freshly evaluate progress on PlanBench and to consider directions for doing well on the benchmark. Unlike the LLMs that came before it, O1 seems to be trained to be an approximate reasoner, not an approximate retriever. Okay, so this is really interesting here, right? So LLMs, it's according to them in this case, it's okay, maybe I should type it out, sorry about that. LLMs, they are approximate retrievers, right? Which means they are only able to retrieve information from their model weights. And right now, here they say, right, it is, yeah, right. It and the mean by approximate retrievers is that okay, given input X, can I retrieve the most appropriate Y as the response? That's what they mean by appropriate retrievers, if I understand correctly. But right now, they say the LRMs, right? It is an approximate reasoner. So essentially, what they meant by approximate reasoner is that, okay, if you have like X and Y, right? And in order to get to Y, you need to have the correct chain of thought. In this case, it would be a reason to believe that why the variable Y is appropriate, is correlated with X, right? So essentially, this LRM is trying to find the appropriate. It is trying to retrieve the most appropriate reason and use that to make the prediction, and that's why it works so well in maths and physics, right? So, but we have to keep in mind that it is still a retriever, nonetheless. All right. Okay, so let's go down here. As you can see in the camera, so someone is up at the top, but I hope that doesn't distract you from the paper. So now let's go through the next sentence here. Okay, following OpenAI, they draw a distinction between previous LLMs and LRM, right? As its new unknown architecture, operation, and capabilities all seem to be fundamentally different than those of vanilla LLMs, both at pre-training phase and at inference time. Okay, about this, I wouldn't say it's fundamentally different, right? all they really did, from my understanding and from their own paper that's called Let's Verify Step by Step, they essentially take the same architecture of GPT-4, but they just implemented some kind of a fine-tuning procedure, right? Such that it enhances the model's ability to reason, right? But the transformer architecture is still the same regardless. All right, but but that's also a bit of a speculation here. I could be wrong, right? After all, it is a proprietary model, and we don't actually know much about it precisely, right? But we have some ideas. Okay, to probably to evaluate this kind of model, right? It would require new tools, blah blah blah, right? Especially if the details are kept secret. Okay, and that's OpenAI, my friends. Since PlanBench has been debuted on Archive, they have continually retested new models on one particular subset, a static dataset of 600 3 to 5 block problems. Okay, and they say here that even though LRMs have become larger and larger and require more investment per model, their performance on the simplest planning problems it's still kind of bad, right? It doesn't even saturate the test set. So yeah, and the improvements that they see are not robust and generalizable. Yeah, so basically it is just fitting the curve, but it doesn't really generalize to the test set, which is kind of bad here. Okay, so the benchmark is a useful marker for LLM progress, right, on planning and reasoning tasks. Therefore, it is important to note that this analysis, especially when confined to a static test set, can only serve as an upper bound. Okay, so right, it can only serve as an upper bound of its performance, right? So what do they mean by the upper bound, right? Upper bound is, if I know, it's like the limits of how good the performance can be. Well, at least that's from my understanding of this term. But let's move on. Okay, right. When the first design PlanBench, it was intended to be just more than the set, but but rather to be an extensive set of tools for evaluating their planning abilities. Now that LRMs score so highly on at least some parts of the original test set, these tools have become even more important for evaluation. Right. Okay. So in this preliminary evaluation at time of writing O1 preview and O1 meeting have been out for a week, right? And the full model, right, is yet to be released. Yeah, I think it will be released around next month, maybe. I'm not so sure, but at least according to OpenAI's own blog post, it seems like the O1 model is like scoring twice the amount of accuracy as the O1 preview model. So yeah, we will have to wait to next month, I think. Oh well. Okay, so so they examine performance jumps that these new LRMs promise, right? So they've kept track of the slow progress of the LLM since the release of the benchmarks, and they will discuss about things about the O1 performance and how well it does and how expensive it can be, right? But you know what? Let's just get right into it, shall we? Okay, so section 2, state of the art LLM still cannot plan. Okay, this is a very bold statement here, but it's true, it's true. So, okay, Right. So PlanBench is still a challenging benchmark for vanilla LLMs, right? Which is basically your standard chat GPT models, right? Yeah, and their lackluster performance on even our easiest test set lead us to believe that planning cannot. Okay, and this is what they believe at that time, right? Planning cannot be solved by approximate retrieval alone, right? So, in table one, right, they present the results of running the current and previous generation of LLMs using their static test set of the blocks world problems, as well as another set of 600 semantically identical but syntactically uh, obfuscated. Wait, hold on. I need to know how to pronounce this. Give me 1 second here. Yeah, it isn't doing much, right? Okay, maybe I should just use Google. Pronounce. Sorry, my English isn't the best, as you can see right here.
Obfuscated.
Obfuscated. Okay, maybe it's not too bad for me. Okay, opposite. Okay, right. Okay, what's the meaning? Okay, right, unclear. Okay, right. I'm just gonna say unclear. Syntactically unclear instances, which they call mystery blocks. World. All right. So across these models, right, the best performance on regular Bloxroll is achieved by the largest llama model with 63% accuracy, right? Despite the underlying problems being identical, right? Somehow the llama model kind of sucks in the mystery version of it, right? And even say not even 5% of accuracy on their test set, which is interesting here. Because like if you think about it, right? So it's like when they say it is syntactically unclear, right? It it means that the object changes in like color and shape, if I'm not mis- mistaken. Is it? Yeah, yeah. They say it is semantically identical. That means the meaning of the text must be the same, but somehow the arrangements are different, right? It has to be right. Yeah, semantic and syntactic right here, right? If you think about it, right, the LRMs back like a few months ago, there's like a theory behind LRMs that stated that LRMs doesn't really understand semantics of what it learns. Instead, it only knows like, okay, right, if I have this token right here, right, syntactically, right, in relationally, what should be the next one, right? But it doesn't really like understand the meaning behind each token and why having one and the other together makes any sense, right? So I guess that's why when you try to change the syntactics, right, the results drops significantly because after all, LLMs, right, it relies on the syntax, not the semantics, apparently, right? So that's just a hypothesis, and it's pretty clear here. Uh, so okay, right, okay, and they say okay, right, and they conclude that the performance on one version of the domain does not clearly predict the performance of the other. Basically, there's no correlation at all, right? Yeah. So, okay, in the original paper, they tested both natural language prompts and PDDL and found that LLMs perform better uh, On the former, even when the prompts can introduce uncertainty due to polysemantics and syntactic ambiguity, right? So in order to make their comparison fair, okay, the results that have reported that they are reporting are the higher accuracy language prompting numbers. Okay, so LLMs are highly capable in providing translation between equivalent representation. Wait, just a second here. Okay, just had a sip. Let's continue. Okay, this fact combined with their significant high performance in the ordinary version of blocks predicts that if they're capable of composing reasoning operations, right, the performance gap between the mystery version and the ordinary blocks world version should be small, right? It should achieve about the same accuracy because the semantics are the same, right? But like I say, right, it relies on the syntax, not really on the semantics, right? That's why it drops that bad. Okay. However, when we provide this in the prompt, performance only improves by a very small amount. For example, up to 10% for GPT-4, which is very bad. So, okay. And they found that, contrary to previous claims, one-shot prompting is not a strict improvement over zero-shot. Okay, so this is kind of bad, right? So if you guys don't know what one shot prompting is, let me have an example here. So let's go into here. Right. Okay. Sorry. Okay, I will accept it. Okay, so what one-shot prompting is essentially giving a concrete example about like, okay, right, I want you to predict the y from the x, right? But in addition to that, I will give you an example that you can learn from, right? So in this case, right here, we ask it, okay, generate a recipe for chocolate chip cookies, right? So that's the question. And now we are going to give it some examples here, right? So an example of a proper recipe is blah, 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 right? So in a way, it is trying to guide the model to produce a valid response, right? However, for zero shot, you completely do not give it an example. Instead, you just directly ask it to do it, right? So what's interesting to me is that, right, one-shot prompting does not necessarily improve over zero-shot prompting, which is kind of nuts, right? And they even say for many models, right, using one-shot prompting actually makes it worse, right? So let's, okay. So, and say, okay, the original iteration of their benchmark did not take efficiency into account, right? As the time taken by a vanilla LLM to produce some output is only dependent on the length of output, but otherwise independent of the semantic content or difficulty of the instance, right? And here's another interesting thing, right? Is that for OpenAI's O1 model, right, the so-called the LRMs, right, it is its computation time actually depends on the nature of the query, right? So if you ask it something pretty complicated that might require a lot of reasoning steps, it is going to run for much longer, right? Because it is an adaptive system in this case. And they say that, okay, and because of that, they say it is important to measure their efficiency, right? So let's go through the next part right here. Okay, part 3, from approximate retrieval to approximate reasoning, evaluating O1. All right. Okay, and here they say many researchers have argued that the standard LRMs generating outputs via approximate retrieval is impressive for System 1 tasks, but they are unlikely to produce more System 2-like tasks, right? Which requires a lot of reasoning capabilities in order to plan ahead, right? So for those of you who do not know what System 1 is, right, we have this right here, which I searched a long time ago back then. So, okay, right here, essentially, System 1 is your intuition-based approach in solving a problem, right? Okay, if I ask you what 1 plus 1 equals to, you would say 2, because that's your intuition, right? But that doesn't necessarily like but you don't use any kind of like reasoning steps. Whereas for System 2, right, going back to that question of 1 plus 1 equals to what, right? Right, if you want to apply System 2 thinking, right, with all the intentional reason steps, right, it would be something like this. So let's see, there is 1 equals 2. Okay, so I don't know if you guys know about this, but essentially, right, even for the simplest stuff like 1 plus 1, what is 1 plus 1 equal to, right? Yeah, if you apply System 2 thinking and you are trying to prove that it equals to 2, right, then you essentially have created the Principia Mathematica, right, which is essentially a long piece of a long piece of literature here that's like around 162 pages, which contains a lot of rigorous proofs and lemmas, right? That tells you every single step that's required to get to the point of proving that 1 plus 1 equals to 2, right? So this is essentially System 2 in hypermode in this case right here. So that's a fun trivia there. Okay, right, next. Until now, the best way to coax sound planning capabilities is to use external verifiers in a generate test framework. So essentially, we have some sort of a feedback system, I believe, though that is not really gonna work that well for most cases. Anyway, okay, and this is called LLM modulo systems. Okay, look, I haven't heard of LLM modulo systems before, and I think it would be nice to go through it some other time. But let's continue, shall we? Wait, hold on. You know what? You know what? I take back my word. I will actually go into it. Just a little while. Okay, right. This is another paper. Right. Sorry about this. Let's quickly go through what LM module is. Ah, crap. Sorry. Okay, just zoom in. Yep, so System 1, System 2. Okay, an informal account of viewing an LM is a giant external memory. Okay, so yep, try to see if I can quickly understand this, but I don't think I can. Okay, guys, okay, I will cover this one in the next video, but But for now, let's continue. All right. So O1 attempts to supplement an underlying LLM with a system to like abilities in a very different way by not using an external verifier. Okay, as far as they can tell, right, O1 combines an underlying LLM, most likely a GPT-4o architecture, into a reinforcement learning training system, right, that steers the creation, curation, and final selection of a private card reasoning traces, which we already know it's in the Let's Verify step-by-step paper if you don't know about that. Okay, exact details are not that much, but they can only speculate about the exact mechanisms. So their best guess is that there are two major differences between O1 and LMs, right? Which is the reinforcement learning pre-training phase, and to say perhaps to learn the Q values of different chain of thoughts from a massive amount of syntactic code data, right? And a adaptively scaling inference procedure, right? Right. Maybe it further refines the learn Q values by something like rollout before selecting a particular chain of thought. See reference 3. Okay, regardless, what looks clear from the detail available is that this model is fundamentally different in nature from previous LLMs, but you have to remember that it is still a transformer architecture. It's right. It just goes through a different training process, right? A different fine-tuning process in this case. So, all right. Evaluating LRMs on the original test set. So they tested out O1 preview and O1 mini. O1 mini kind of sucks apparently. On the static test set of uh, their benchmark. Okay, and the full results are available in table 2, blah, blah, blah. Okay, right. There's 600 instances, right? Requires plans between 2 to 16 steps, which is pretty difficult. Okay, far surpassing any LLM, they found that the O1 model correctly answers close to 100% of these instances, right? However, this is this happens again, right? However, when you use the mystery version of the benchmark, it only gets 53% correct. I mean, it is still much better than GPT-4, which only gets like 10%, right? But the fact that we go from 100% almost to 50%, right? There's something going on here, right? That even OpenAI still haven't figured out, right? How, right? And this kind of tells us that maybe there is like a fundamental limitation in the transformers architecture, or maybe there's a problem with the RL system that we have been using, right? No one really knows why, but in this case, we can confidently say that this, despite having this a new RL training paradigm, it still doesn't manage to understand the semantics effectively. But it does improve this sort of understanding compared to LLMs, but it's not perfect yet. Okay, so next, okay, to test whether the exact obfuscation might be compromised because of data contamination. Okay, and they say, well, this sort of accuracy boost from like 10% to 53%, maybe it's because there's some training data about it, right? So, okay, so they generated a new obfuscation using completely random strings and presented these problems in a new semantically equivalent prompt format with fully specified and ambiguous PDDL descriptions of both the domain and the problem. Okay, and this new version is called randomized mystery blocks world. All right, and they say, well, in this case, they could be right here. They say the performance of the O1 model drops further. Just about 37% of the instances are answered correctly, right? So, so in this sense, right, what this means is that there's definitely some contamination in this case, but not that much, right? I mean, it would be more interesting if they create like maybe 50 different semantically equivalent prompts just with different syntax, right? It's like having 50 of them, right? And measure the average accuracy, right? Because right now, right, we don't exactly know for sure whether or not it's the variation of the syntax is the issue, or maybe it's just about the data contamination here. We don't exactly get to know here. But anyway, let's move on. Next, accuracy with increased problem size. Okay, standard LLM chain of thought prompting approaches are pretty brittle, and it does not robustly scale with the problem size, and it fails to induce general algorithmic procedure following, right? And they tested out the models on the set of 110 problems, right? Right, and the problems in the set range from 6 to 20 blocks in length, and it requires 20 to 40 steps in the optimal plans, right? So okay, and they say, right, without any obfuscation, they see the performance degrade from their nearly perf 100% score uh, reported earlier, right? In fact, the OR model only gets around close to 24%, right? Which only means one thing, that yes, it can plan for up sorry yeah for up to like 16 steps, but as soon as you go above that, right, it quickly drops in accuracy, right, which is pretty bad. Just give me 1 second here. Oh, okay, right. Okay, let's see. Right. So where are we now? Okay. Right. And they say most of the accuracy gains actually comes from correctly solving problems that require less than 28 steps, right? So in that case, the distribution of correctly answered questions would be something like this, I think. Where here is like, where here could be 28 or something like that in the ballpark. Yep. So that's for O1. Okay, and now let's take a look at performance on unsolvable instances. Okay, right. So while planning problems normally require the agent to formulate a course of action to achieve a goal, right? An equally valid use of planning is to recognize that a given goal cannot be achieved by any plan. Okay, right. So an example of this is network vulnerability analysis, where an agent wished to certify that no plan of attack can even exist for that particular system. So far, LLMs, they say, have been struggling to recognize some problems that cannot be solved. Instead, they hallucinate nonsensical answers, basically, which is pretty normal here. Okay. O1 was launched with the claim that it has started to overcome this issue and can now accurately identify unsolvable problems, right? So, in order to test that, they modified the 100 instances from the original benchmark by adding one on by adding one on XY type uh, conjunct to each instances goal, right? Making the goal to be unaccomplishable. Okay, so they basically have some instances, right? Basically, they changed the 100 instances to be unsolvable, essentially, right? So, okay, and to say, okay, on Block's world, right, only 27% of all instances were correctly and explicitly identified by O1 as unsolvable. Only 27%, right? And the 19% of all cases, right, the model returned with a dot, so something like an empty plan. Okay, interesting here, without any explanation on why it's unsolvable. Okay, okay. I would say that just by having a dot and an empty plan, I think that's pretty good. Okay, right? It doesn't come up with anything, and I think that's acceptable in my case, right? Okay, so they consider these incorrect, as empty plan is the only correct answer if the goal is already satisfied. Okay, I think the authors here are a bit too harsh, but it's their opinion here, whatever. In the remaining 54 cases, the model generated a full plan, but it's obviously impossible and incorrect. However, yeah, so overall it doesn't perform that well, as you can see, even though if we take the 27% and the 19% to be a success for O1, but the fact that it's like only half, it's a half win and half lose, which basically means that you can practically throw a die, right? I mean, you can throw a coin, you can flip a coin, and the chances would be 50-50 would be exactly the same here in this case. All right. So on randomized benchmark, the, the numbers are only 16 cases are correctly identified as unsolvable, and 5% is the empty plan, and the remaining 79% are answered with a full but nonsensical plan. Right. So with the randomized and mystery benchmark, it's even worse. Right. So overall, it's pretty horrible. Okay. Right, how many more? Okay, right, so we are in the last page. That's good. So now let's quickly go through it. Okay, so last part here: accuracy, cost, trade-offs, and guarantees. Okay, with the O1 model being a better planning model, right? Okay, their evaluation, okay, obviously needs to take the accuracy and cost trade-offs. Yep, because after all, it's pretty expensive, as you can see it on table 4 here, right? If you use Claude 3.5 Sonnet, it only costs you like around half a dollar, whereas for something like O1 Preview here, it, it costs close to $50, really. So yeah, it is pretty expensive here. Okay, so, okay, and to say, while O1 may provide higher accuracy, it still fails to provide any correctness guarantees, which basically means that it's not even like 99% accurate, right? Okay, and it's unclear whether or not it's cost effective at all, right? Okay. Unlike previous models whose APIs only charge based on the number of input tokens and the number of output tokens. Oh yeah, right. Right. There's another point that I want to say is that there's a Google paper that showed that you can, okay, right, empirically, right, in order to get to the correct answer, right, what they essentially did in that paper, I forgot what the name is, but the idea is that you perform like thousands or maybe like a lot of inferences, right, generating answers over and over uh, again, and the chances of you hitting the correct answer actually increases along the way, right? So maybe we can take that into consideration in this case, but obviously they don't in this paper. But yeah, maybe that's something to consider as well, right? Is that as long as your model inference price is cheap, then maybe it could be better than O1, but honestly though, right? If it requires like 100,000 inference, I don't think that's gonna work out. But anyway, right. So let's continue. Okay. Usually at a rate that is 5 times higher for the late for the latter. Okay. O1's price per call. Blah blah blah. Okay. Right. Right. So the price includes for the number of reasoning tokens. And the reasoning tokens are actually the tokens that's produced as part of its reasoning procedure, right? But the sad part is that even though when you pay that much for the reasoning tokens, they won't show you the reasoning steps, right? Instead, it only gives you the overview, the summary of the reasoning procedure, right? So yeah, but you still have to pay for it, which kind of sucks. Okay, yeah, which is what they say here, not revealed to the user, right? Even though you have to pay for that. Right. And they say here, okay, since the launch of these models less than a week ago, we have already run up a bill of around 2000 USD just for the O1 model experiments on this benchmark. Yeah, so this paper is quite expensive here. Yeah, I'm pretty sure OpenAI is making a lot of money in the meanwhile. Okay, right. And to say the early version of the O1 model that they have seems to be limited in the number of reasoning tokens it uses per problems, as can be seen in the leveling of figure 2 and more clearly from the scatter plot of Pen Explorer. This may be artificially deflating both the total cost and the maximum performance, right? If if the full version of O1 removed this restriction, this might actually improve accuracy, but it could also lead to even less unpredictability and ridiculously high inference costs. Okay, right? I can I can taste the the tears from the authors here. Yeah, so O1 Mini is cheaper, but it's kind of bad. Okay, right. Okay, right. Okay. Here, without exposing the ability to scale inference time to particular specifications, influence the internal thinking process in task-specific ways, or ensure the intermediate steps are evaluated by trusted or sound verifiers. The O1 models are okay, and they call it a coarse grain choice in the space of cost and inference, inference time guarantees and performance trade-offs. They are not the only choices in the space. right? And reasonable LRM evaluations must take this into account. Cool. Okay. Let's see right here. All right, and now right here they are practically saying that, well, why do we even need O1 to solve this when we have like a heuristics or classical algorithms that can solve the same damn thing but essentially cost $0 and it is much faster. In this case, it would be things like downward, which is a classical algorithm that achieves 100%, right, for free, right? And each time you launch it, right, per test sample, it only requires like less than half a second, right? Right. And they also argue that, you know what, you can probably just use the ordinary LLMs to like translate the problems between different syntax, right? Right. Although that doesn't work necessarily quite well, but it does its job somewhat, right? And they also say that, oh yeah, how about just use the LRM modular system, right? Which is basically, okay, you run a smaller, faster LLM in the loop with a verifier system, right? So that the combined system will only output guaranteed correct solutions, right? So So yeah, and in some previous testing, they showed that the LLM modulo system can already achieve up to 82% accuracy on the original test set, which is pretty damn good, right? Although it doesn't quite achieve near the performance of the original O1 preview models, but it does pretty well in this case as well. Okay, right. Okay. The correctness guarantees provided by the two approaches, right? The one classical approach and the other one, the LM modular system. Their correctness guarantee property is something that the O1 model does not have, right? So, okay, and they say that a general reasoning system cannot be deployed in safety critical and non-ergodic domains if it continues to confidently make incorrect plans. Okay, so right here, right, for those of you who do not know what this word means, non-ergodic, let's go to Bing right here. Okay, right, right. So ergodicity is the idea that the average outcome of the group is the same as the average outcome of an individual over time, right? And being non-ergodic means that it's not the same, right? It's not equivalent, right? So, which basically means that the average outcome of the model is not the same, right? That's the average outcome per sample, right? So in other words, there's a lot of variability, right? So when things have a lot of variability in its accuracy, right, in its predictive ability, right, it's not safe to use it in like things like I don't know, like in healthcare or maybe even in the military, right? So it kind of sucks at that. Yeah, and O1 is practically a black box system, much like the other LLMs, right? Right. And it is also the fact that OpenAI decided to hide the chain of thought reasoning steps, right? Right. And a complaint here, which I really like. Thank you for this. Yeah, and OpenAI tries to warn away and even ban anyone who attempts to understand what what the chain of thought and reasoning traces are. in the system, making interpretability nearly impossible and reduces trust in the system overall. And that's completely true. Even though when it provide like a summary of the reasoning traces, right? Yeah, there's a problem that I have with with the summary of the reasoning traces is that even the summary isn't that accurate in itself, right? It is like, okay, it provides you an arbitrary step-by-step reasoning trace, but if you actually look close into it, right, step one might not actually be much related to step two at all. It, yeah, right, it is kind of like pseudo understandable in that sense, which makes exactly like what they say, right? It's not really that trustworthy after all. Okay, right. And the final part here, O1's creative justification. Okay, I wonder what they mean by creative justification here. Okay, well, their focus in this paper has been on providing a quantitative evaluation of O1's performance on PlanBench. They have noticed an O1 idiosyncrasy that's worth mentioning here. Okay, right. Like I say, my English isn't that good, but idiosyncrasy basically means a strange habit. Okay, right. A strange habit that O1 has. Okay, all right. When the model has given a correct answer, it also sometimes provide a creative but nonsensical justification for its decision, right? It is it is almost as if O1 has gone down from has gone down from hallucination to gaslighting. Um, in one case, it decided that an unsolvable problem is solvable because a goal condition, while not present in the final state, had been true at some point during execution, and thus it should count and it should continue to count. In another, it declared that on A and C was true because it explained in a brief parenthetical, A was on B and which is on C, and was thus A was somewhere above C and should count as being on top of it. As I mentioned earlier, they changed their unsolvable instant prompts from natural language to PDDL in order to make it extremely clear that divergences from our exact definitions was disallowed. Okay, right. Basically, what this means is that it's making stuff up. It's hallucinating, right? Hallucinating to the max in some cases, right? Right. Obviously not all of them, but I really do like this part right here. This heading right here, creative justification. Yeah, I think the authors here they are being like uh what's the word for it? Snarky? Is it snarky about it? Is it yeah, exactly, right. They are snarky about the O1 model, which is pretty hilarious here. Yeah, okay. So, what have we learned so far? I guess basically there's a lot of things to work on now. It's like, yep, O1 is great for like physics questions and maths, but if we give it something else that's out of the distribution, right? Which you cannot find the reason, right? Because after all, O1 is just retrieving the reasoning steps, right? And then see whether or not it can like fit in to the questions that you are asking it to do, and it does it well sometimes, and it doesn't do that well for for some other tasks here. Yeah, but yeah, yeah. So overall, this is a pretty eye-opening paper, right? So maybe OpenAI, right? OpenAI, please, OpenAI. reduce the price, please. It costs $2,000 just to make this paper, right? I mean, it's even more than that when they have to like test it out for the other models as well, which is kind of nuts, right? Okay, right. So yeah. All right. So apart from that, if you guys are still here, yeah. So please do check out my Patreon, right? And make sure to become a member here, right? And I will see you guys in the next video. Bye. Okay, turn to close OBS. See ya.